Okay guys, this is going to be a very, very short video on how to find the molecular formula of a compound. This is kind of the last part. It's a much smaller notes portion than the empirical formula one. And you're going to have a few problems on your homework sheet at the very end of this video that I will walk you through, so you may want to have that handy. So grab a sheet of paper, grab something to write with, and let's take a few notes. I'm going to also give you some clues and answers to your assessment video that you will have on the wire later today. Okay, so remember that the empirical formula contains the smallest possible whole numbers that describes the atomic ratio. The molecular formula is the actual formula of the molecular compound. Okay, an empirical formula may or may not be the molecular formula, meaning sometimes you may have the empirical formula also be the molecular formula. So let's take example BH3. Okay, we know that the ratio of atoms is 1 to 3. Any multiple of BH3, such as B2H6, B3H9, B4H12, and etc., okay, represent the same ratio of B atoms to H atoms. Okay, these would be considered molecular formulas, okay, because these are not the lowest ratio possible. This would be the empirical formula of all these. In addition, this could also be a molecular formula, okay. Obviously, the multiple here would be 1, multiple 2, multiple 3, and multiple 4. Okay, so the expression that will help you get the right formula is this right here, and I will give that to you on any test or assessment that you're asked. Okay, we're not really going to so much use, though, this top. We're going to be using a form of the bottom one here, okay, where we look at the masses of the relationships, the masses of the empirical formula and the masses of the molecular formula, and solve for some value of what we would know we would multiply. Okay, so for example, most of the time in the problems that I give you, molecular formula mass is always given to you. Okay, it's given in the problem. You are either given the empirical formula mass or an empirical formula that you have to find the mass yourself. And so what you're going to be solving in problems for these is some value x. And so if we do a little algebra and rearrange this formula to read as x equals molecular formula mass divided by empirical formula mass, then we can take the data given in any problem and solve for that factor or that multiple that we would multiply. So let's do a problem down here. We're going to do two types. One where it's just kind of straightforward. I'm going to give you, this is your homework, 5, 6, and 7. I'm going to do a little bit of each one and help you set up. And by the way, you might hear my kids in the background. Okay, so in this set of problems, it says determine the molecular formulas for the compounds having the following empirical formulas and molar masses. So in each of these, the first compound that's given is the empirical formula. The experimental molar mass, this is your molecular formula mass, okay? So the first thing you need to do is find the empirical formula mass of C2H4S. And so 2 times 12 plus 4 times 1 plus 32 would give me a mass of 60. Okay, and remember this is the mass of that compound. Then to find your value x, you're going to take the mass of your molecular formula, which is 179, and divide it by the empirical formula mass, which we just found was 60. When I do that, I get a factor of x equals 3. Okay, and you're going to hear my kids in the background here soon. Once you get your x value, okay, then you can take that x value and multiply that against your empirical formula. Okay, and when you do that, it's going to give you a new formula, C6H12S3, and this would be considered your molecular formula. I write a little big, so I kind of wrote into that extra area. Now, C, B, and D are all done the exact same way, so you should be able to do those pretty easy. 6 and 7 are a little bit longer. 6 and 7, you're going to have to actually find the empirical formula first based on the data that's given. Okay, and so if you look at the data that's given, 0.7 grams of chromium, this should be 0.65 grams of sulfur, and 1.3 grams of oxygen. Okay, these are not given into percents, they're already given into grams. And so to find the empirical formula, grams to moles of each of those, okay, divide by the smallest, and then find your empirical formula. Okay, remember your mole ratios are the subscripts that you would get on your formula. Once you find your empirical formula, find the mass, and then solve everything up above. This number here that's given in the compound, that is your molecular formula mass, just like we did above. Okay. On number 7, same type of problem. You have to find the empirical formula given the data. It says a sample of histamine having a mass of this is composed of 208 milligrams of carbon, 31 milligrams of hydrogen, and 146, that should be milligrams of nitrogen. FYI, the 385 is extra information. Okay. You can use those pieces, those datas, for milligrams, solve for grams, go from grams to moles, and then use the molar mass of the compound in the very, very last step. Okay, so try a few of those. I'm going to give you a few problems on the wire for you to try